Hello, everyone, and welcome to today's panel discussion on digital twins. My name is Aaliyah Pollock, and I work as an AI data and technology analyst at the Royal Institution of Chartered Surveyors, also known as RICS. For those of you who aren't aware, we're a leading professional body working in the public interest to advance knowledge, uphold standards, and inspire current and future professionals. Our members help to create and protect the built and natural environments that are sustainable, resilient, and inclusive for all. We work inclusively with our members, supporting them in their practice and building valuable connections. With a heritage spanning over 150 years, we set qualifications and independently regulate 110,000 chartered members across more than 140 countries worldwide, guiding decision makers with trusted data and insights to help shape public policy and deliver positive societal change. As part of my role here at RICS, I manage the RICS Tech Partner Program. For those of you who aren't aware, the Tech Partner Program, it's a collaborative platform for innovative data and technology that produces thought leadership content and market insights for the profession. By partnering with tech firms working across the entire property life cycle, we help our members to understand and adopt digital solutions that bring real value to their professional activities. In doing so, we ultimately aim to bridge that gap between the surveying profession and tech innovators, ensuring that the adoption of emerging technologies enhances the value we bring to the built and natural environments. Given the broad range of asset types and pathways RICS cover, the topic of digital twins is it's very big at the moment. Digital twins can be applied in various ways, helping our members across different industries and asset types, whether it's urban planning or real estate management. Today, we have a fantastic panel lined up to discuss the various facets of digital twins, as well as their real world applications and how they're transforming different industries. We'll explore the future challenges in adopting this technology and the skills needed to leverage it effectively in the future. So, without further ado, let's introduce our panelists. Adam, starting with you.
Thank you, and thank you very much for the opportunity. So let me introduce myself in short. So I'm Ádám Korbuly, the CTO and founder of Orthograph, and also the founder of a facility management system called RTFM, which was the first ever BIM-based facility management system, let's say, starting going back to 1998. I am by profession an electrical engineer and also a software developer. What I'm representing today here is the concept of operational BIM, which is about the concept that we are trying to implement all around the world to provide that kind of BIM model that is well usable and also maintainable during the total building life cycle, starting from the construction, or let's say beginning of the construction, till the end of demolition period of the buildings. So we don't focus on the designing part, even though I was working for Graphisoft for a while, so I've also participated in the development of RICS and REFM. Still, we focus on the operational phase of these buildings.
Thank you very much, Adam. Siddharth?
Hi, Aaliyah. Hi, everyone. My name is Siddharth Kumar. I'm the CEO and founder of Eartheon. Now, Eartheon is a digital twin platform for the built environment, so to speak, but also the natural environment. The view we are bringing to the digital twin is that it has to be able to adequately describe the system under consideration, whether it's a built environment or the natural environment. We use systems thinking to understand all the actors at play, and we try and integrate all the data, both structural and functional data, into describing the system. And we are focused on operational KPI monitoring of a built system of any scale. It could be at the level of one building or go all the way up to cities and so on. And we are also trying to bring in some prediction and simulation to these large, very large systems. That's what Eartheon is focused on.
Thank you very much, Anthony.
Yeah, so Anthony Peake, CEO, founder of Intelligent AI. We are very much focused on the built environment, on property, residential, and commercial, but very much with a insurtech, proptech view. So working very closely with insurers, with brokers, with chartered surveyors to deliver data that identifies risks and values buildings. But we're doing this on millions of properties and globally. So it's really about how do we gather all the right data to be able to deliver that to all of our community.
Thank you very much. And last but not least, Mohit.
Yeah, hi, good evening, everyone. My name is Mohit. I work very closely with my founder in the founder's office for Fabrik. Fabrik is a spatial computing platform wherein we make 3D digital twins accessible, affordable, and easy to use. How we're able to achieve that is by using our web-based no-code editor, wherein we're able to unify data from any source, whether it be PLM, SCADA, images, text, videos, whatever, and we're able to integrate 3D along with live data points, and then we distribute that across the value chain to be able to make smart decisions quickly. Along with that, we also build a lot of AR and VR-based applications as well, purely enterprise-based.
So thank you very much for our panelists for their introductions. So kicking off, I think it's important to start by defining what a digital twin is, as it's crucial to understand this foundational concept when discussing its applications. For me, in the simplest terms, a digital twin is a virtual replica of a physical object, system, or process, often updated in real time through data collected via sensors or other technologies. Digital twins allow us to simulate, monitor, and analyze the performance and status of physical assets in a digital environment. So, to kick things off, I'll direct the first question to our panelists to explore how they define and apply digital twins in their respective sectors. So, Adam, I'll start off with you. How would you describe a digital twin, especially in terms of operational value in sectors like healthcare and retail?
So actually, operational BIM is, as it says its name, it's about operation, which means that it's not a technically differentiative BIM from the regular BIM that we call, which is typically, let's say, understood as the IFC files or CAD formats. It's about a different concept. I would emphasize three main pillars of this concept. The first one is that it must be easy to capture. So if you speak about a hospital, then these hospitals typically are already there, already standing, already in use. That's the same thing with all of the, or let's say most of the corporate real estate, most of the buildings. So it must be very easy to capture. When we speak about capturing, we don't speak about only that kind of beam that how does it look like. So it's not about the beauty contest. It's about having clear and accurate data about how many square meters are the usable area, the service area, what's the condition of the building. In addition to this, how does my inventory look like? What are the maintenance points in this building? Because maintenance points, or let's say inventory, how we call it, are required later on for supporting the operation. So capturing the data is the first main pillar. The second main pillar of operational BIM is that making this data available for the operation. So when we speak about operation, we don't speak about architects, even though BIM is very much connected to the architectural world. We speak about maintenance people working on site. We speak about decision makers, financial directors, CEOs of companies who are not architects again. Still, they want to run, for example, a graphical report about how does my tenancy look like. Where are those rental units where we will have rental contracts finishing within the next month, let's say. So maybe I can rent out the whole stuff together to a new tenant if they are sitting beside each other. So making it available, making it accessible. So in my opinion, the most important point is to have a mobile view for the maintenance people so that they can access the data on site. And at the same time, they have to have a web view, a 3D, 2D web access. Typically, 3D is better than 2D because people typically, or let's say non-technical people typically don't understand floor plans. So therefore, if there is a 3D view, then they can understand it better. And I speak about a web view because that every people have on their computer, a web browser that can run these models, these views. And probably the third and most important conceptual pillar of this operational BIM concept is that it has to be kept updated by the maintenance crew. So it has to be able to record all the changes when and where they happen on site. Post-its or notes that will go to the architect somewhere outside or inside of our company will not work. So I have seen it several times failing, and that's why I say that that's the third and most important point or benefit of this kind of operational BIM. Once we have this operational BIM, once we have an inventory of assets with unique identifiers like using RFID chips or barcodes or anything that can be used to identify these items uniquely, then we can start thinking about building up workflows. We can start thinking about controllable workflows. So I would say that operational BIM compared to the BIM is that I would say this is about financial things. It's about money and workflows, and not the beauty contest of the typical BIM, how we or how architects understand that.
Thanks. And continuing on this topic of how it's used in the operational space, Siddharth, how would you define digital twins within the scope of sustainable city and property management?
Nice, Aaliyah. So when you talk about cities, we are obviously looking at a much bigger systems, and then there is always this question of who is this twin intended for. So the way we approach building twins is who's going to use this twin. So it turns out that there is a pyramid of users. Obviously, there are people at the top, there are people at the middle, and there are people at the field, and there's an entire hierarchy of people who are going to be using twins. And so when you're looking at a super large system like a city, you're really looking at the kind of parameters that each one of this hierarchy wants to be monitoring. So the guys at the top want to be looking at the most strategic aspects of the city, and so they have their own frameworks, such as sustainable city frameworks, or so on and all that. But the guys at the operational level might want to be looking at something more operational like ESG, ops, or particular department in cities and so on. So when you build a system, I think you need the most comprehensive description of this entire hierarchy, as well as all the subsystems that are involved. So what we do typically is to we start at the top level frameworks, such as a sustainable city framework of some sort of a gazillions of them, and each city has its own framework that they want to use for whatever strategic reason, and start working down to the data, where it actually happens, like sensors and traffic data and IoT data and so on. So, like I said earlier, the twin for us is to be able to, describe the system in its entirety. Entirety, of course, is not possible. The most comprehensive description of the system for decision making at every level. That's what we're trying to do.
Thank you. And continuing on this topic again with operational digital twins, Mohit, is there anything different you'd like to add there, particularly in terms of digital twins application for smart cities and critical infrastructure like manufacturing or transport?
Yeah, absolutely. So just like how Siddharth pointed out, every system is unique in its own way. So when it comes to us, when we build digital twins, we work very closely with governments when it comes to smart cities. They have their own set of rules and the way they would like to build these digital twins. And that's where having a very flexible platform to be able to accommodate all of these changes is really important. And we're dealing with extremely sensitive data as well. So just like how Siddharth mentioned, when we have traffic data, when we have people data, when we have AQI and things like that, most of it is pretty sensitive and they're not happy with letting it be out there in the open. So for us, when we build those digital twins for smart cities, for just as an example, one brilliant one that we're working on right now is trying to reduce the number of fatal accidents that happen along a roadway. So how does a digital twin help that, right? So being able to build a flexible solution wherein you're able to integrate vehicle data, you're able to integrate people movement data, where you are able to triangulate cell phone locations and then give you a sort of a high level view of how many people and how many vehicles and things like that. You can kind of simulate these situations and prevent accidents from happening. That is something that is super cool that we're working on with right now. And another great use case was where we were talking about controlling the movement of people in a city to keep the AQI at a much lower level, keep it at a healthy level. So we're combining public transport data, we're combining people movement data, traffic data, and also public services all together into a single digital twin, manipulate them here and there to be able to move people away from high AQI danger zones to low AQI danger zones, move high polluting vehicles to other places. So you would kind of bring down the AQI to a safe level. These are some interesting cases that we're working on with smart cities right now. The most important part, of course, is making them accessible to the right people at the right time so that they can make decisions quicker. So that's something that we're doing right now.
Thank you very much. And last but not least, Anthony, I'm interested to hear your thoughts coming from a strategic perspective. So how would you define digital twins in the context of insurance and risk management, and how are they being applied in your work to identify and manage insurance risk across different properties?
Yeah, it's interesting. A lot of people are talking about the sort of city landscape, etc. But still, it's a common theme of property. Digital twins to us are the same sort of thing. It's bringing together a set of data to describe a real world element. In our particular case, in insurance for property, there is a model called COPE, C-O-P-E, Construction, Occupancy, Protection, Environment. And across there's probably about 200 pieces of data. So where is it? What is it? How big is it? What's it made of? What's it used for? Crime, natural catastrophe, flood, earthquake, etc. But simply it can be describing it's a perfectly safe office building, but it's next to a petrochemical plant. Or it's next to a synagogue with geopolitical risk, or it's that kind of thing. So it's really, as humans, we spend 80% of our time doing admin and 20% of our time adding value to our companies and our customers. And so by delivering a digital model rather than people having to physically go out and measure the footprint or the height or work out the number of stories in a building or, to pump pressures, valves, etc., we're able to deliver a digital twin of the risks of a property and give a 360-degree view of the risk across very large multi-million property portfolios. Similarly, we've also applied that to valuing buildings. So the traditional task of a chartered surveyor of bringing in information on the footprint and the height and the number of stories and how much for demolition and how much for external works, etc. We can now automate that entire process and then allow people to apply their professional capabilities rather than just manually going out trying to find the data. So a digital twin helps people to manage risk. It helps people to set the right level of insurance on a property. And in the future, it'll also help in defining the carbon footprint of a property, but doing that using AI, satellite, open data, proprietary data, but doing it all quickly within cloud environments.
Thank you very much, Anthony. Now that we've defined digital twins, let's dive into the real world applications and the tangible benefits that they offer across all of the various industries that our panelists work in. From enhancing efficiency to supporting sustainability, as Anthony just mentioned, digital twins are changing the way in which we approach infrastructure, facilities management, and urban planning. I'd like to now talk with our panelists and explore how digital twins are delivering measurable benefits. So, Ádám, I'll start off with you again. Going back to your experience with hospitals or retail spaces, for example, how would you say that digital twin technologies can benefit these assets throughout their entire life cycle?
Actually, I would separate the two areas very much from that point of view, that if we speak about hospitals, then there the most important goal is to save as many human lives as possible, so to make the hospital as efficient as possible. In case of shopping malls, for example, or retail spaces, the goal is the same from that point of view, that the efficiency, so to achieve the highest efficiency, highest productivity of these buildings is the same, but there is no human life risks. So it's more about money. So if you speak about hospitals, for example, let me give you some real-life examples that we have seen. So first of all, I would say that, for example, if you have the proper digital twin and operational BIM containing, for example, these unique identifiers, then we can build up a cleaning control, which means that we can only believe that the proper ward or any kind of room has been cleaned properly if there was enough time spent. So just simply scanning an RFID chip when the cleaners enter the room or leave the room, and after 10 days, we have 10 examples that are 10 samples that what is a typical time requirement of cleaning that particular room properly. Instantly, we can build up a control to see, okay, if the time is different, if the current time that's spent on the building or the room is different than the normal or the average, then that's something to review. That's something to check. The same thing is that if we have a digital twin, then we can say that you don't need to go to building G wing or second floor analyst with a long description that probably the new employees even will not understand. But if there is anyone working on the building and can get a link to the given asset that needs to be maintained, let it be a room, let it be a machine itself, then they will instantly find it. They will have a location, a navigation to the given location, which shortens downtimes. And shortening downtimes means that the buildings will be more efficient. They will be more usable than if we need to wait for the maintenance works to be done. The same thing, if we have these unique identifiers on the assets, then we can say that we have a breakdown report, and we don't need to explain that where we did find that particular problem, but instantly by scanning a QR code, scanning an RFID chip, we can instantly connect it to the given location. And it's a typical problem. Let's say what I experienced in my life is somewhere 30 to 35%. It can go up to 30 to 35% typically that the maintenance people don't find the maintenance points that they need to repair. So they just going around the building, looking around, and they don't find what do they need to do. So therefore, that's a very important point as well. Fluctuation, and that's true for hospitals, true for everything, that there is a fluctuation in the maintenance people. So if the knowledge is only stored in the heads of the people, then we will lose it once they leave the company for any reason. If we have a digital twin, if we have one single source of truth digitally stored locally at the property of the building owner or stored in a software as a result, it doesn't matter. Then if anyone leaves the company, then a new person can get access to the same kind of data. So it means that it's an instant onboarding of these subcontractors or of the employee as well. Tendering. If we speak about tendering, then we want to reduce the time the tendering needs, and we want to rely on accurate, available data. Let it be an inventory, let it be calculated painting area, cladding baseboard area, anything that is required for an innovation. If we have these data in our hands instantly, then it means that due to the shorter tendering periods, the downtime, so the unused times of these buildings become minimal on one hand. On the other hand, in case of tendering, we can rely on real, accurate, measured data. So it's not something that we are assuming that, okay, this might be our cleaning area. No, we will clearly know it instantly. Graphical reporting I mentioned previously. That's about the retail space management part. That we can say that if we clearly know what is the how the building looks like, and we have these numbers accurately, then on one hand we can make appropriate contracts with this with the new tenants, but we can also use this technology, for example, for sales purposes. We can say that, okay, let's make a layout together with you as a prospect standing in the rental unit. That would this layout be good for you? And then showing this to the prospect, then they can decide, okay, I would like to have this place or not. Or even if they say not, then you can instantly show another alternative. So it means that it's an easier sales process. Construction documentation. During construction, we can get access to the maintenance points that might be hidden later on behind the ceiling, behind the artificial floor, or in the walls. So we can record a building documentation. That documentation can be later on very well used, highly improve the maintenance efficiency of the building operation. And there are even many more. So I would say that the digital twins and this kind of digitalization is crucial for all these segments. And now we have the opportunity to do this now because of the technology possibilities.
Thanks, Adam. And Siddharth, moving across to you, I know Anthony had touched on sustainability and how digital twins can help aid that in the future. But looking at digital twins today, how would you say that they can advance sustainability and efficiency in urban and property management?
Aaliyah, so sustainability again at a city level, involves a lot of data aggregation and data normalization, because that kind of data is coming from all kinds of sectors. So when you define sustainability at an urban level, and you start going down that data point, you will notice that it is spread across several areas. It could be urban infrastructure, it could be ESG metrics, it could be all kinds of things. So one of the things that we do is to try and define the depth to which the data needs to go for urban planners or policymakers. What is the depth to which, how many degrees of data depth do you require? And how does this need to be represented on the twin? So the twin, in our view, needs to be both a structural twin. Where is this data point spatially located? But how does it also work with other kinds of data? That's when the system dynamics come in. One of the areas that we look at is the coordination problem. In fact, something as simple as laying a road requires coordination, a very complex coordination between several parties, the underground infrastructure people, the compliance people, and the regulations, and so on. This is not so much a spatial problem as a system problem. Who does what and when. So those are the kind of urban dynamics that we believe that we need to be concerned with also during the construction of a twin, and that's one area that we're focused on as well. This complex coordination of a system, apart from the spatial aspects of the twin itself, such as BIM or CAD or GIS and so on and all that. These are two broad areas that we need to focus on, and that's the area that we're looking at.
Thank you. And Mohit, moving across to you, could you share an example where digital twin technology has led to improvements, especially in with the type of projects and asset types that you work with, and what led to significant improvements, specifically in efficiency or cost savings?
Yeah, absolutely. So there's this really fun project that we worked on that we're still working on. This is for an oil and gas facility that's situated in India. So let me give you a little bit of context. So from my personal experience, there's a lot of stigma around using digital twins because they're exorbitantly expensive. And then once you deploy them, whoever deployed them may not be around at the company to see the results, because results from digital twins take a lot of time. It's an expensive affair, and by the time they start reaping their real rewards, you're already long gone. You're in another organization. So trying to fix that stigma around digital twins is something that we've been working on, especially with this oil and gas facility. We work with another partner who provides the data. So what we've done over there is basically created a bird's eye view of the entire facility, wherein we've focused on attaching data points to critical, crucial, and critical and crucial components in the oil and gas facility. And the trouble with an oil and gas facility is downtime is expensive, and they're all in hostile locations. So if something goes wrong, it's going to take forever before you can get it back up and running. So that is where being able to integrate live data that comes from the partner along with the 3D layer, which is your bird's eye view of the facility, becomes immensely valuable. So once you integrate that data and then you distribute it on thin compute devices like a tab or a VR headset or a laptop or whatever it is, just like how Adam mentioned earlier, having that data available as a web view is extremely powerful. 3D running on the browser is the next best way to consume information. So when that is available with people on the ground floor, on a tab wherein you are monitoring the facility, an alert pops up, that's great. And that's where all digital twins today end, just identifying a problem or saying, hey, something is going to go wrong at tank 101. That's where all digital twins end. But what is really valuable is if you provide actionable digital twins. So you build a digital twin and then you attach 3D SOPs or 2D SOPs or whatever it is. Give people the ability to make decisions on their own without having to call 50 different people. Or in case you can't do that, even provide them with remote assistance, like a collaboration feature or something, where they can quickly get on a call with 3D as an interface, your rear view camera to see the actual asset in operation, and then have a subject matter expert in the same place. You're able to cut down on decision making by about 50% right there. So whereas the digital twins that we were working on with this oil and gas facility, we were able to see a 25% improvement in overall operations, because we're able to trigger alerts and then tell people how to fix it immediately. There's no time lost. And communication up and down the value chain dropped by about 50%, which was amazing to see. So we have the C-suite guys who are using VR headsets looking at their own facility from anywhere in the world. And then we have mechanics and operations guys sitting at the field in AC offices on a laptop, and then on the field with iPads, and they're all seeing the same thing. And very rightly put by Adam, like the single version of truth is so important. Something we've seen with other digital twins is that single version of truth does not exist. They only integrate with data that they feel like integrating with, if I may say that. But being able to integrate with everything is where real value lies, and providing actionable insights is where real value lies. And that's where digital twin needs to go as the next step. Make information easy to understand, easy to consume, so that you're able to do things quickly. That's something that we've worked on and we've seen tremendous success with.
Thanks, Mohit. We've all mentioned this single source of truth, which is great that we're able to integrate that in properties now. But unfortunately, with existing properties, there often isn't that single source of truth, and the data is hard to find. So, Anthony, I know that Grenfell Tower fire had a profound impact on the industry. I'm curious on how did this event influence the creation of your company, and how does digital twin technology play a role in enhancing safety, risk reduction, and operational insights in building management to prevent such disasters?
Yeah, I mean, I started Intelligent AI about 4 years ago. Prior to that, I'd spent the last sort of 7-8 years actually building out risk and underwriting platforms for some of the leading insurers: AXA, QBE, RSA, Amlin, Aviva, all the majors. And most people were developing a system for their internal use to basically present the legacy data they had. So they weren't real time, they weren't interactive. And when Grenfell Tower happened, 79 people have lost their lives through Grenfell Tower. It will cost the insurance industry over 2 billion because there's carcinogenics now in the grounds and it will cause cancers in the future, etc. So these things don't just happen in one point, they go on for a very long time. I've been looking at just some basic data. You know, how often has the fire service visited a property, and is there a model you can build that would predict future incidents? And there'd been 11 call-outs to Grenfell Tower in the year leading up to the fire, but no insurer was collecting that that sort of probable data. They were predominantly waiting until after a disaster and then working out what should they have known. We've, go forward now, I think there's been another 4 Grenfell Tower like fires with cladding on the outside in Dubai and up north in the UK and in other countries. And so I very much wanted to drive forward to there is a better way of doing something. We don't have to wait for a disaster to happen and then analyze what went wrong. There are enough data sets out there, many of which need cleaning. Many of which need to have a proper model to attach them to. But 4 years later, we've got to the stage now where one of the things we had to do even was to develop an engine that fixes addresses, because invariably in the insurance industry, less than 40% of the addresses are usable. And how can you define the risks of a building if you don't know where it is, or if your pin is about half a kilometre away from the building? How do you know how close it is to a flood, etc. So we've created a platform now that brings together all of that data about, in the case of risk, about 150 pieces of data. In the case of valuations of buildings, about 30 pieces of data. But we're literally at the stage now, Mohit was talking about, they can take a long time to build these models. Actually, we're building those models in real time. We can type in a ROPI address. We can lat long it, UPRN, unique property reference number. We can geospatially tag it, and we can bring in all of the risk data or all of the valuation data in about 10 to 20 seconds. And then we can score every single part of that. So, when things like there was another property in Florida, 8777 Collins Avenue, that collapsed overnight. In the middle of the night, the whole thing just collapsed, apartment block. Within 24 hours, and I would say that's slow now, but within 24 hours, we'd actually used AI to go out to the local council, bring in the latest survey that was on, extract the data out of there, build a digital twin of the building, monitor social media and bring in imagery of it, having 3D satellite, street view, to walk around the property, etc. We knew that the slab of the pool had been built flat rather than sloping, and the water wasn't going off. We knew it had ingressed into the car park, and the concrete in the car park hadn't been designed for water. We had pictures of surveys done 6 months before that nobody had acted on, showing the balconies collapsing. And we could create a forensic view of the incident within 24 hours that would normally have taken insurers and other people maybe about 3 months, 6 months to actually work out. And so you've got all of those incidents. When you look at, and I'll finish off on your question on this point. When you look at the rebuild cost side, for instance, I've been working very closely with Lloyd's of London and with a number of major insurers. I brought in a portfolio of 355 properties and looked at their existing insurance valuation. Commercial properties are between 1 to 20 million, average about 14 million. 355 properties is a small portfolio when you're talking about hundreds of thousands of millions. With 355 properties currently insured for 5 billion. We put it through the platform, instantly built the digital twin, revalued them, should have been insured for 6.73 billion. So it's only 1.17 billion underinsured. It means the insurers lost out on about 2.8 million of premiums, but it also means that at 43% of that portfolio is over 30% underinsured and at risk of not being paid out. And so this is really the vision. Yeah, there's different views of digital twins, whether it's in insurance, whether it's an extension of BIM into construction, but ultimately it's the speed at which we can get that insight. Then the professionals can apply their skills, rather than having to do the admin of gathering the data.
Thanks, Anthony. And just a quick follow-up question. I'm curious to understand how widely adopted digital twins are in this sector. Often when it comes to digital twins and technology and real estate, the industry is slow to adopt it. But given the risk and impact on life that insurance has, how widely adopted do you see it being used?
Technology adoption and transformation is the same in any industry and any subject. If you can get a quick win project that excites everyone and shows the art of the possible, it'll take off. If you can demonstrate a significant saving in operational costs without too much disruption of the organization when first installing it, it will take off. So I'm actually finding, and also in many industries, skills are running out. The average risk engineer now is about 58 years old. Many of them are either just getting ready to retire or will be retiring shortly. The industry is not able to hire, breed, promote enough people with those skills. So actually what the big focus and where the organizations are seeing a reason for them to change, and you have to deliver that reason for them to change, is that we can free up those expensive and highly skilled people to work where they're needed to focus on mitigating risk. And we can apply their knowledge into models to build then a digital twin that will then allow us, because today they're actually only able to survey 20% of a portfolio, so they still have no data on 80% of the portfolio. So with a digital twin, they're able to deliver a synthetic model of 100% of the portfolio and then apply the real skills, the humans, where the need is to actually go and mitigate the risk.
Thanks, Anthony. So moving across onto our next topic. While digital twins offer significant advantages, as we've heard from our panelists, there are also huge challenges when it comes to their adoption and deployment, whether it's data privacy, integration, complexity, or ensuring the technology remains up to date. There are hurdles that must be overcome so that we can fully maximize their potential. So I think it's important to discuss some of these key challenges faced by industries when adopting digital twins and also the future opportunities that we can expect. So Ádám, I'll start off with you. What would you say are some of the typical hurdles that facility managers encounter when integrating digital twins, and how would you say that they can be best supported, and what should they do to overcome this?
Actually, we already mentioned it a little bit that it takes always a lot of time to capture digital twins, or let's say that's the assumption that it takes a lot of time, a lot of efforts, and it's very expensive and it's difficult, etc. This is something which have to be, and which we have solved actually with Orthograph, that capturing data becomes very rapid. So we speak about days and weeks, even in a 60,000 square meters office park. It takes, let's say, 2-3 weeks to collect all the information for these properties. That's the first point. The second point, what also Anthony mentioned, that skills are running out. So once we have a digital twin, then it's really hard to find someone who can understand why is it good for, how to use it, how to benefit from it. So in my opinion, and how we approach this problem is that let's make everything simple as it is possible. So if you don't need educated people to keep it updated, if you don't need people to have long learning curves to use such a solution, such a digital twin in the operational phase, then it can be successful. If it would take a lot of time, then it wouldn't be. And actually, that's what I tried 20 years before, that saying that, okay, we have CAD systems, we have ArchiCAD, let's use it for facility management. And then we needed to hire highly educated people, let's say expensive architects, for doing something that they don't like to do, that really they hate it, because they learned on university to do nice buildings and not to maintain old buildings and the changes in those buildings. So that's a point that have to be solved, and we also have solved that. And the third problem that was there and that have been solved is that any kind of documentation. So if there is a BIM, even if there is a BIM model of a building, and typically there is nothing, but if there is a BIM model, it's on one hand lacking of lots of data, so there is no inventory of the maintenance points. On the other hand, if there is anything, then it becomes obsolete in weeks or maximum months. And to keep it updated was a high amount of cost. So that's what we were focusing on. And solving these problems, it becomes now more a BPR task to help them to understand, okay, from now on you have to do it differently, and these people have to do different things than they did before. So that's my opinion about that. That this is something to be solved, and that's something that we also solved in a way with our technology.
Thank you, Ádám. And Siddharth, I'll move across to you. Are you experiencing any of the similar challenges, or is there anything specific that you experience when deploying digital twins for large-scale city projects? And how are you navigating these challenges?
Right. Ali, I'll make reference to some points that Anthony made about not having enough data, even at a very granular level of, let's say, a building or a building complex and so on. So you can imagine how complicated it is when you're dealing with very large systems. So there are seriously big data gaps. And in the context of a city, you also have the natural environment that we mostly ignore, which means, the cities, there is a natural environment and then there is a built environment, and the data gaps are really sparse. So I'll give you an example from something that we did. We're working on a very large port in the Middle East, and then one of the requests that the client wanted is that if I drag and drop, let's say, a future building that I want in one aspect of my site, now, what would the repercussions of something like that would be? Essentially, what he's saying is that he wants to understand how it will affect traffic flows or the container flows or all the interconnected systems. So when we went about looking at the data that they had, each data is in one stage of maturity. Some of them are simply on paper or some scanned PDFs or whatsoever. So you can imagine the kind of problems that you have. There are data gaps, and there is also a data level, the data maturity level for every department that is very heterogeneous, that is non-uniform. So you can imagine the complexity involved in the city. And so one of the problems in adoption of digital twins is because of these data gaps, what is the level of certainty with which are we able to tell the client that this is the action that you need to take, or so those are some problems in implementing a twin. There are gaps. There are very few standards of data interchange between these systems, and then there is not even a consensus on the kind of parameters that you need to be looking at the top. So this goes into all kinds of economic parameters and political parameters and so on. So clearly, one of the problems that you will face when you're looking at really constructing a twin of very large systems is that what are the KPIs and parameters that we can agree upon? So a lot of these problems are really not even technological sometimes, but what can we all agree upon? So it almost becomes socio-political.
Thanks. I mean, we've covered a lot there. Mohit, is there anything else you wanna add on this point with challenges or any other potential ways that we can overcome these barriers?
Yes, and I'll try to keep it brief as well. So, I'll just start off by saying that every digital twin is as unique as a human thumbprint. So it's very difficult for companies to constantly create a standardized platform or a standardized method of creating digital twins. Like you can't just say that, hey, this is your set of data that you fill in and that's your digital twin. It's not that simple. So everyone comes with their own unique challenges. Everyone comes with their own unique way of solving problems, their own SOPs, their own, socio-economic structure, whatever. So at that point in time, what we thought, let's flip it around, let's make it as easy as possible for people to start building digital twins on a platform like us. So you start off with providing people with being able to integrate any kind of data that they want. So you don't put limitations on what kind of data is there, because like Anthony mentioned, the data is a huge issue. But if you know what it is not, then you know what it is. It's like the principle of elimination. So you try and build your digital twin starting there, so you have like a strong place to begin with, and then from there you can start building your own data sets, by working with the organization, or you bring in another partner who's able to create new data for you to build off those foundations, and then you're able to start building more full-fledged digital twins. At that point in time, you're taking baby steps. So it's not too much of a drastic change. You're integrating into an environment which is not too, you're not changing too much around when you're integrating with their environment. So being flexible and being able to integrate with various forms of data, distribute on any kind of platform or any kind of device, not have device limitations, things like that makes it a lot more easier to overcome these issues, so that you're able to hit the ground running immediately and start solving problems. So you can see digital twins, instead of taking 12 months to build, they would probably come down to maybe 12 weeks or 16 weeks.
Do you ever, just continuing on that with you, Mohit, do you ever find that, I mean, you say they take 12 months to build, do you ever find that the solution is too complicated for the problem? And how do you ensure that you're always addressing the problem first?
Yeah, so there are a lot of so I'll tell you it this way. So we had the typical customer lifecycle for what I've experienced. So I've been at Fabrik for about 2 years. Fabrik has been around for 7. The first 2 years that I spent at Fabrik was just educating people on what digital twins are and what you can use them for. So that is where the customer lifecycle starts. Just knowing what it is and what it can do, and then they come back a year later, and then they're like, "Hey, I think I have your tech or digital twins might solve this problem. What is your feedback?" So we get into that whole loop of consultancy, and we try to understand what their problems are at a grassroots level, and then we tell them, "Hey, you know what? If you add this, you will be able to solve this problem." So just to give you a quick example, we were working with Wipro for an automotive manufacturer in the US, wherein we wanted to build a digital twin of every single car that is sold by a dealership. So that basically ties into asset lifecycle management, and you're able to create a record of every single part, every single maintenance, every single user for every single car that is sold. So when it comes to that, there were a whole host of problems where they said, like Anthony mentioned, the talent is disappearing. And like Adam had mentioned much earlier, people have all this tacit knowledge and it's not being transferred anywhere. So, at that point in time, a digital twin can only do that much. So at that point in time, you have to figure out other tools and techniques to solve them. So where it does apply is by helping them with 3D first applications so that assimilating information is easier, storing information becomes a little easier, and then we go from there.
Thank you. And one final point that we haven't mentioned. So we've mentioned how we need more data, and with more data, we've got increased accuracy. Anthony, I'd like to move across to you. With increased accuracy, especially with digital twins, there does become this risk of data privacy. How do you handle the concerns around data privacy in creating digital twins for insurance purposes?
Yeah, it's quite interesting. I mean, we a lot of the data that we're using is open data, proprietary, but models that we use in some areas AI. We wouldn't use machine learning. We don't want black boxes that make decisions without being able to audit all of the data. That feedback loop of if you quite often insurers will build a lot of data on very large corporate sites because they're profitable. They will have very little data on SME sites, which are the majority of businesses that we all thrive from. If you start building digital twins that define SMEs as being more risky, those businesses could go out of business. They could fail to get insurance. So there is an ethical side to it. But equally, we've made it a point to always look for 3 sources of every piece of data, to be able to audit where the data comes from, to be able to have algorithmic confidence scores in every piece of data. So whether it's the height of the building, the area of the building, what the roof's made of, the walls made of, etc. And so for the insurers, privacy is key. We absolutely assure and ensure the privacy of the data, but we're fortunate or unfortunate that we're in an industry that will want us to complete 100 different due diligence documents and test everything before they will go live with any system. So you build robust systems, and we build on Azure, and there are plenty of models on how to build robust systems, allowing users to be able to query, how did you come up with my model? I disagree with the score that you've given. Who do I write to? Having that type of information on your website, not just assuming that you'll be nice to society, but actually giving them a way of actually interacting with it. And so I've worked with the Alan Turing Institute and a number of other institutes on the sort of efficacy of the data and how do we make it that people can interact with their own data. But ultimately, the privacy of the data is a given. And systems have enabled us to do that, and just good thinking. The quality of the data It's an interesting point, and back to your point on transformation, etc. I often use humor and reality. If I have 3 risk engineers in a room and I give them a risk report, I'll get 4 scores. If I have 3 chartered surveyors in a room and I give them a property, I might even get 4 values. So, quite often industries are basing their knowledge on data of 20% of the portfolio and extrapolating the rest. But the moment you try to do something digital, they expect everything to be 100% correct. Yet they're working from a world where they've only got 20% of data themselves. So you have to have a bit of reality. If you've got multiple sources of the data, so that you've got algorithmic confidences and you're sort of 95% correct, then the machine has removed 75% of the costs of a process. The humans can then look at and say, would I treat that top floor as an attic? Or if it doesn't have enough windows and doesn't look as though it's been converted enough, I would probably ignore it just as I wouldn't treat it as a floor, I'd treat it as an attic. Would I treat that as a basement? If it's a listed building, I wouldn't try to do a model of it. I don't know that it's got a £900 kitchen or a Rennie Mackintosh panel of something. So obviously I'd send a chartered surveyor there to actually look at the property. But if I can automate 95% of the task and free the people up to then be able to do 4 times as much business in adding their professional skills, we all win.
Thanks, Anthony. All of us have touched then upon the skills of what's required in the future, which leads us on to our final topic that we'll quickly run through. So as digital twin technologies become more integral to various industries, the skill sets required to manage this technology are evolving. We need to ensure that professionals across different sectors have the expertise to effectively implement and manage digital twin systems. So to conclude today's session, let's explore how digital twins are shaping the workforce and the new skills that will be required moving forward. So Ádám, I'll start back off with you again. In your opinion, as digital twins become more prevalent in facilities management, for example, what skills are required to effectively use and manage these systems?
Actually, first we should investigate what are the new opportunities, because there are many. And to benefit from these new opportunities, that's what we have to investigate. What kind of skills do we need to access these kind of opportunities? So formerly, facility managers were typically controlling what's happening in their operation. So they were questioning whether you have done this or you have done that. So from this point of view, it must be changed to a different approach. First of all, they need to become really managers, understanding that now they have valid data, they have real life data. And by benefiting to access this kind of data, they can make real decisions. So it means that data analytics, data analysis becomes very important. On one hand, this is also true for the other side, that we many time hear that we need a BIM manager who will maintain the BIM models. No, BIM managers has to be much more a financial kind of person. So people who can analyze the data and can evaluate what kind of decisions are the most beneficial for the efficiency of the building operation. So it means that we need people, instead of people who are designing and maintaining this BIM data, those people who can analyze this data and help the decision makers with enough background to be able to make the right decisions on site. So in my opinion, on one hand, needs a little bit less education from that point of view. It's not that technical, not that difficult on one hand. On the other hand, needs more education, because these people, not only the decision makers, but also the BIM managers, has to be able to understand why is it good for, what's the purpose of this whole BIM, of this whole data that are in their hands. On the other hand, for the maintenance crew, so for the people who work on site and do the dusty work, I would say that they don't need to. BIM can only be implemented if they don't need to learn anything new, and if they are already experienced with using mobile phones for social media and for watching videos online, etc. If that knowledge is enough to access a model and to understand how to go to the proper location to access the additional documentation, maintenance manuals, videos maybe, that they are anyway used to see, then they can be also asked, okay, guys, if you change something, then please update it in the model the same way. And if it doesn't need special knowledge, then we are fine, because then we have then an always updated model in their hands without making big changes within the company. So if we can minimize BPR, so business process reengineering, just saying that, okay, guys, a little bit more on the maintenance side, just to record what you have done, not on a paper, but now digitally in your phone, as part of the facility management activities. And then this data becomes available for the decision makers instantly, then we can speak about that we are benefiting from BIM, and we are also speaking about higher efficiency and lower operational cost. And that's my opinion about that it's really the right time for do this change, because the knowledge is in the people's mind already there.
Thank you, Adam. And Siddharth, moving across to you, how would, taking this into consideration, what Adam's just said, how do you say that the role of urban planners and property managers is going to evolve, especially with greater emphasis on sustainability?
Right. So, I think systems thinking is the need of the hour, and the property management people and urban planners have seen themselves more as designers rather than system designers. So far, given the climate change and sustainability issues and so on and all this, I think the property managers and urban planners need to see themselves as a part of a larger system and start developing skills, in some sense, cross-domain and transdisciplinary skills, because essentially all these people are trying to develop systems. So I guess the thinking has to move from sort of seeing themselves as designers more to system designers. And so they will have to now try and talk to several other people who are stakeholders in this whole system. That, I think, is a big shift. And of course, the usual stuff about the digital transformation of how we deal with the kind of data that the city is producing. But that's going to be the more obvious stuff, like how we can BIMify everything, try represent everything in 3D, have common data standards, have frameworks, and so on. So on, I think, are the usual stuff. So, but I think, like you said, Aaliyah, people have to see themselves slightly differently, and not just data wranglers.
Thanks. And Mohit, I'll move across to you. What would you say are the key skills required for the future, and what do we need to do to address that?
I mean, I think it has to start with the very basics, I mean, like tech has moved so much in the last 5 to 10 years that a lot of people have got left behind. And I think it's just, you need to like revisit the past, start with things that were working fine before, and then just implement those first, and then start building on top of them. Just to give you a very basic example, right? So when we were working with a bunch of these manufacturing companies where we were building manufacturing digital twins for them, just having just basic data sets available was a huge problem for us. They were using 40-year-old SCADA systems, 40-year-old PLC systems. I mean, it became quite impossible for us to build anything from there, right? And they had no idea that IoT had moved this fast in the last 4 to 5 years. So I think companies need to start thinking about, just making a positive small change, like a 10% win in every department. Just improve by 10% in every department first before, you see an overall change. I think that is where people would need to start off first, especially with, the way tech is moving so fast. I mean, just as another just simple example, we did not have photogrammetry a while ago, and making photogrammetry run on thin compute devices is something that is super cool and is just developing, is just booming now, and we're using drones to do that. We didn't have access to that a long time ago. So it starts with the basics, and then you build on the basics, and then you get to something really cool. I think that's where things need to start moving before we see like real change.
And thank you, Anthony. What do you think for traditional roles in the insurance industry? Which roles would you say need to adapt or be replaced for more tech-focused positions, especially as digital twins gain more traction?
Yeah, it was interesting. I was at a conference yesterday, and there was a talk. I hear this a number of times. Organizations need to become digital organizations with insurance as a sort of add-on to it. Or you can say that to any industry. You need to become a digital organization. The interesting thing for me is we need to accept that a lot of the decision making in organizations is white, middle class, and older people. And some of the greatest innovation comes from young, ethnic, and less well-off people. And so therefore we need to really prize the different skills within our organization. It was great yesterday at an event I was at, one of the biggest insurers, just like people used to lock down social media, only certain people in the organization are allowed to communicate on behalf of the company. And then eventually people realize, no, you just unlock it and let everyone do it, and we're all reasonable. Same with data. They were looking at AI and things like OpenAI and ChatGPT, and should we lock it down? And they realized, no, we should put a data lake in the middle of the company that everyone can log into. And they're seeing some of the greatest ideas for the future of insurance coming from the young people who have been given access within meters, with some guardrails on, and certainly with privacy, but they're seeing new thinking and new ways of doing things. You know, if you look in your membership and the chartered surveyors, many of the smaller companies are struggling for business, but yet at the same time, most people only get a quarter of their portfolio valued each year. So now you can get to the stage with automating having 100% of the portfolio valued every single year. That creates a lot of edge cases of listed buildings on more expensive or complex sites to then promote the skills of your membership to go out and visit those sites. So actually with data will come more opportunities. And I like that idea of the people who are making the decisions are like me and getting very old. We need to provide that data in an unfettered but protected way to the younger skills of every race in order to really be innovative.
Thank you, Anthony, and thank you to all of our panelists and to everyone engaging with us today. Today, we've heard from our panelists about how digital twins are shaping the future of industries like insurance, urban planning, facilities management, and more. As we've seen, they hold huge potential to improve efficiency, reduce costs, and drive sustainability, whether that's today or in the future. The technology's evolution is exciting, and with the right skills and support, we can look forward to a future where digital twins are a core part of our built environment and day-to-day lives. RICS will continue to work closely with our members and our tech partners to ensure that they're equipped to leverage these innovations and stay ahead of the curve. So thank you once again, and I look forward to continuing this conversation in the future.
Thank you very much for the opportunity.
Thank you.